A polynomial function is any function that can be written in this format, where n is some non-negative integer and then the coefficients a sub n minus 1, a sub n minus 2, and so on are real numbers. Now, in standard form, a polynomial function is written in descending order of the variable. The degree of the function is determined by the highest degree term. And typically the highest degree term is written first, and then the terms decrease in order after that. Graphs of polynomial functions are always smooth, continuous curves. So you would never have a graph of a polynomial function that had any type of discontinuity or any type of break or any abrupt changes in direction, like the absolute value function has kind of a corner in it. That's not the graph of a polynomial function. All polynomials are going to be smooth, continuous curves that maybe look like that. So the functions that you've looked at with our 12 basic functions that are polynomial functions are the identity function. The degree of that function is 1. The squaring function. The degree of that function is 2. And the cubing function. The degree of that polynomial function is 3. Now each of those polynomial functions only has one term. With y equal x cubed, for instance, it is understood that there is an x squared term. Its coefficient is just 0. There is an x term. Its coefficient is just 0. There is a constant term. The coefficient is just 0. You've also learned with the handout on investigating end behavior that what the end behavior is for a polynomial function that just has one term. We can actually extend that, and let me make a little room here and slide this down out of the way, slide this out of the way, and we'll get to zeros in just a second. But you can extend your observations of the end behavior of polynomial functions to all polynomial functions, not just ones with one term. The end behavior of the graph is determined by the leading term. So for the function f of x equals 2x cubed times x minus 1 times x plus 5, first of all, the degree of that function is 5. If you multiplied this out and got this polynomial written in standard form, the leading term would be 2. X cubed is multiplied by x and by x to give you x to the 5th power. So looking at 2x to the 5th power, we know that the right end behavior, the limit as x approaches infinity, is positive infinity, and the left end behavior as x approaches negative infinity is negative infinity. So we also need to talk about zeros of a polynomial function. The zeros very simply are the values of x that make f of x equal 0. They're also referred to as roots or solutions to the polynomial equation. So if you're given a function and asked to find the zeros, what you've got to do is set the polynomial x cubed plus 2x squared minus 4x minus 8 in this case. Set that minus, hello, there we go, equal. Alright, my pen's not working. Pause. Okay, so we set the function equal to 0, or we set the polynomial equal to 0, make an equation. And then we're going to solve that equation. This one we can do by factoring. If we factor out an x squared out of the first two terms, leaving x plus 2, factor out a negative 4 out of the next two terms, leaving x plus 2. Then, of course, your common factor is x plus 2. The other factor is x squared minus 4. X squared minus 4 can be factored as x plus 2 times x minus 2. And the zeros we get from setting each factor equal to 0. We will get x equal negative 2, x equal negative 2, and x equal positive 2 for the zeros. Now, when you've got a 0 that repeats, because that 0, x equal negative 2, is used twice, we say that's a double 0. Now, we could write that polynomial function because x plus 2 is multiplied by itself. It's used twice. We could rewrite that function this way. Okay, and the fact that the factor x plus 2 is used twice indicates that we're going to have a double 0. That also tells us that the multiplicity of the 0, the multiplicity of x equal negative 2, that double 0, is 2. The multiplicity of the 0, x equal positive 2, is 1. So you can determine if you have your function factored like this. Look at the powers on the factors. Whatever the power is on that factor, that tells you the multiplicity of that 0. Now, pause the recording and I want you to get your calculator out and I want you to graph our function f of x. Okay, now remember that this is our function f of x. You can enter that equation into your calculator exactly that way. It can be in factored form.